Hello everybody, I hope you had a great spring break. To start the day today, what we're going to look at is our last unit, which is Unit 6. So we're starting with statistics. So hopefully this will be an easy lesson to get you back into the groove. I know it's hard to get started after a long week. It's hard for me as well. So most of this, well, all of this you will have seen before, but you need it all for this unit. So we'll go through, how to find these different things as well as the mean absolute deviation. So, and then you'll have a little practice assignment. So at the top, we're just going to kind of recap what all of these words represent, and then we'll go through some examples of finding those. So the first one is the mean, which is also called the average. Okay, and to find an average, you add all the values and then divide by the number of terms, so however many data points you have. The median is the middle value. Okay, the important thing about the median is you have to make sure it's in order from least to greatest and then find the middle value. Otherwise, we would all get different middle values if we put them in different orders. So median is the middle, put it in order from least to greatest. Mode is the number that occurs the most often. You can have no mode. You can have more than one mode. You can't have exactly one. So this is the only one where it's possible to have more than one. Pen is not working. Okay, everything else, you should just have one mean, one median. Range tells you how spread out your data is. So that's going to be the difference in the highest and the lowest value. So you'll see maximum minus minimum, and that will tell you your range or how far apart your numbers are. The mean, the median, and the mode are all measures of center. Tells you a way to measure where the middle of your data is. Range is a measure of spread. Okay, your range does not measure the middle of the data. The last three kind of have to do with box and whisker plot. So I just kind of showed you an example of a box and whisker plot. It has 5 numbers that you have to plot on a box and whisker plot. The lowest observation or your minimum. The beginning of the box is your lower quartile or Q1. You should have a line inside of your box that represents your median. The end of the box is your upper quartile or Q3, and then the end of the whisker is your maximum or your highest observation. Okay, Q1 or quartile 1 is the median of your lower half of your data. That's what this is. And then Q3 or quartile 3 is the median of your upper half. Okay, if you can see, Q2 is missing, because Q2 or quartile 2 is your actual median. Okay, so basically you split it into 4 parts. The first splitting part is your Q1, the last one is your Q3. Okay, so use that to help you find these things down here. So I did 2 different examples because with the median it matters if you have an odd number of data points or an even number of data points. So I want to make sure we go through both of those. So the following were Bryce and Jacob's scores on a math test. Find all the summary statistics and then create a box and whisker plot. So I'm just going to do one for Bryce, not Jacob. So to find the mean, we need to add up our data points and then divide by how many there are. So I'm just going to use my calculator for that. So 88 plus 80 plus 84 plus 86 plus 82. And then we're dividing that by 1, 2, 3, 4, 5. So 420 divided by 5, which is 84. So that is my mean. Okay, for the median, first thing we need to do is put it in order from least to greatest, because this is not in order. So 80, 82, 84, 86, 88. I tried to make this kind of easy here. And then what I usually do is just kind of work my way in, so putting my fingers on the outside and then going in one at a time to find which one is in the middle. And I'm going to circle that because we'll need it for our box and whisker plot. So my median is 84. That's my middle number. Mode, is there anything that occurs more than the other numbers? Okay. Well, they all occur one time, so there is no mode. If you had one that occurred 3 times, then that would be your mode because it occurred more than the other ones. Okay, your range, we take our maximum minus our minimum. So 88 minus 80 gives me 8. Okay, and then my minimum, that's my lowest value, is 80. My maximum is 88. And then I'll show you how to find Q1 and Q3. So we have already found the median. That's why I circled that. And you can see it breaks it into 2 separate pieces. So these 2 are my lower numbers. These 2 are my upper numbers. This is my median, so you can't really include it into one section or the other. So to find Q1, I want to find the median of this section. Okay, well, the median of this section, or the middle, is actually going to be between these 2 numbers. Okay, so if you can tell what's in the middle of those 2 numbers, that would be your Q1. If you can't tell, you need to add those together and divide by 2 because that will tell you the average. But the middle of 80 and 82 is 81. Okay, so that's going to be our Q1. And then same thing over here. I need to find the median of these 2. So the middle right here. So middle of 86 and 88 is 87. Okay, and same thing, if you could average those together, 86 plus 88, and then divide that by 2, and that also gives you 87. Okay. So we're going to take those and make our box and whisker plot. And so we need these 4 numbers as well as the median. So we'll start with our minimum. So we need to go from 80 to 88. So I'm just going to label this, start at 80, maybe leave a space, and count up. Okay. So my minimum is 80, and you can either do a dot there or a little line there. I usually do a dot. My Q1 is 81, so that's the beginning of my box. I'm going to start with a line. My median is what's next, is 84, so that also gets a line. And then my Q3 is 87, and then my maximum is 88. Okay, so the lines create my box, and then you just draw a little whisker out there. Okay, so a box and whisker plot should separate it into 4 parts. There's 1, 2, 3, 4, and they're all equal parts. Okay, right here they all have 1 data point. It's a very small data set, so 1, 1, 1, and 1. So it should all be equal. Okay, so let's do Jacob, and we're not going to draw the box and whisker plot. We're just going to find everything and just make sure we know what to do in the case of an odd number or even number of terms here. All right, so our mean, we add them together and divide by how many there are. So 82 plus 88 plus 90 plus 80 plus 75 plus 95. So that's 510, and then I'm dividing that by 6. So this mean is 85, so he has a higher average. Okay, for median and all these things down here, I need to put it in order. So my lowest number is 75, then 80, 82, 88, 90, and 95. Okay, and then we'll work our way in. So start on the outside. We need to find the exact middle. Okay, so I don't have a number to go to, so my middle is actually between these 2 values, the 82 and 86, or 82 and 88. So you can figure out the middle of those 2 numbers, or you can add them together and divide by 2 to average them. And so the middle of 82 and 88 is 85. So that is my median. Okay, mode. None of the numbers repeat again, so there is no mode on this one. Range is my maximum minus my minimum. So 95 minus 75 is 20. So that's my range. My minimum is 75. Okay, maximum, I'm going to go all the way down there, is 95. And now I need to find Q1 and Q3. So if the median is between two numbers, it's good to just draw a line because you're separating it. This is my lower half. This is my upper half. Okay, because now we can find the median down here. Okay, it is 80. It's actually that number in my data set, so that's my Q1. And then the median on this side is 90. Okay, and you can see it's all equal parts. There's one number here, 1, 1, and 1. So we did separate it correctly. Okay, so those are all of our summary statistics, mean, median, mode, range. You've started learning those in about 6th grade, but it is good to refresh those because we'll be using those a lot. Okay, I wanted to do one more topic, which is the mean absolute deviation, because it's just a good one to throw in with those. It's not really a standard with us, but we'll be going into what's called standard deviation, which is similar. So it's good to just recognize the process of finding the mean absolute deviation. So when comparing two data sets, sometimes we need to know which data set is more consistent. Okay, one way to measure this is called the mean absolute deviation. This tells us on average how far apart our data points are from the mean. So are they close to the mean or are they spread out from the mean? So we're going to use this data set to find our mean absolute deviation, and then I'm going to have you guys go back and try it with Bryce and Bree's data points, or Bryce and Jacob, sorry, I changed the name, and just make sure we're good with that. So before we go through calculating the mean absolute deviation, first thing we have to do is find the mean, because we don't know how far away they are from the mean if we don't know what the mean is. So we need to add those numbers together and divide by how many there are. So I got 144, and then you divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 16. Okay, so our mean is 16. So what we want to figure out is on average, how far away are these from 16? So I like to use this chart to help organize the work. Otherwise, you end up with this long list of things. So if you'd like to utilize this, to me, it's a lot easier, and students seem to use it a lot better than trying to write it out from left to right. So first thing we're going to do is write down our data points. They don't have to be in order if your data set is not in order to start with, because it's not going to matter, but I'm just going to go ahead and write them in the order that they are. Okay, and then we want to figure out how far away these numbers are from the mean. So what we're going to do is take each data point and subtract it from the mean. So I'm going to do 10 minus 16, because that tells me how far away those numbers are. So negative 6. Then I'm going to do 12 minus 16, which is negative 4. 14 minus 16 is negative 2. 16 minus 16 is 0. 18 minus 16 is positive 2. 19 minus 16, 20 minus 16, and then 23 minus 16 is 7. Okay. Notice if I do it in the same order, data point minus the mean, I'm going to get some negatives and some positives. And that's because your mean should be in the middle. Some of them are going to be below your mean, and some of them are going to be above your mean. But if I use it like this with negatives and positives, if I were to add all these numbers together, they're going to balance each other out, and the sum of those values is going to be 0, which is not very useful, because if I do 0 divided by anything, I'm always going to get 0. So what we really want is we want the positive version of that. So a lot of times people will just skip this column here and go ahead to the last column, because we want the absolute value, which means we only want the positive distance. So how far away is it? And then exclude that negative number. So absolute value of negative 6 is positive 6. Absolute value of negative 4 is positive 4. So we're just going to go through and make all of these positive if they weren't to start with. Okay, and now this is going to be more useful because I can average these numbers together. So once I have their distance from the mean, okay, the positive version of that, we're going to add all these together. skipped a number. Okay, and I got 32. Okay, now 32 is not my answer. I need the average of that. Okay, so I already added them and got 32. And now I need to divide by how many numbers there are. So divided by 9. And you do count the 0 as a number, which is 3.5. Repeating. Okay, so my mean absolute deviation is 3.5. Okay, and this is telling you on average how far away are they from the mean. So your numbers are about 3.5 units away from the mean on average. Okay, so if your mean absolute deviation, or your MAD, is a small number, that means your data points are close together because they're very close to the mean. Okay, if your mean absolute deviation is a large number, that means your data points are spread out. So spread out makes it less consistent. Okay, if it's close together, we call those consistent, because your numbers are kind of doing the same thing every time. Okay, so that's not only how to find it, but you need to recognize what it represents. Bigger numbers means more spread out because they're further from the mean. Smaller numbers means they're more consistent, they're closer to the mean, they're kind of clustered all around the same spot. So I want you guys to kind of pause it and try example 3 using Bryce and Jacob's scores. I forgot to change this name here. And you already have the mean for both of those, so you just have to go through and do the chart. So go ahead and pause and try that on your own. And then I will show you these. So Bryce is 84. All right, so Bryce's mean was 84. Jacob's mean was 85. Okay, and we want to find out who was more consistent as a student. So I'm going to do Bryce first. So write down his data points. Okay, and then I'm going to subtract each of these from the mean. So 88 minus 84 is 4. 80 minus 84 is negative 4. 84 minus 84 is 0. 86 minus 84 is 2. And 82 minus 84 is negative 2. And then I'm going to make all of this positive. Okay, and now we just want to average those together. So add them together. So 4 plus 4 plus 2 plus 2 plus 0. That gives me 12. I need to divide that by 5. Which is 2.4. Okay, so this is Bryce's MAD is 2.4. And then for Jacob, we'll do the same thing. It's got a little more data points here. 82, 88, 90, 80, 75, and 95. And then we're going to take all those and subtract our mean. I just grabbed these from the front side. So 82 minus 85 is negative 3. 88 minus 85 is 3. 5, negative 5, negative 10, and then positive 10. Okay, and then make all those positive. And if you want to skip that middle row, you're welcome to do that. Okay, now we average those together. So 3 plus 3, 5 plus 5, plus 10 plus 10. So that's 36 divided by 6, which is 6. Okay, so if we want to figure out who was more consistent, we want to figure out whose mean absolute deviation was smaller. So Bryce was more consistent because his numbers are closer to the mean on average. Okay, so that means they're clustered around that mean, where Jacob was more spread out. And you can see from his data points, he's got 75s and 95s. So that's more of a spread than Bryce over here, who's between 80 and 88 the whole time. So make sure your answers make sense, okay? But they should match what the data looks like. All right, so you guys have a practice quizzes to work on. It just has a few of each topic on there, just a couple mean absolute deviation. Let me know if you guys have any questions, and I hope you're doing well.